measuring the immeasurable, astronomical units, and interstellar distances, explained space is vast. So vast, in fact, that our everyday units of measurement, meters, kilometers, even miles, quickly become meaningless. If the distance to the moon were measured in centimeters, the number would be so large it would lose all practical meaning. Now imagine measuring the distance to the nearest star. This is why astronomers had to invent new ways to quantify the seemingly infinite. Today's journey explores how scientists measure the immeasurable, beginning close to home with the astronomical unit, moving outward to light years and parsecs, and finally venturing into the staggering distances between stars and galaxies. This exploration reveals how humanity has learned to map the universe. The astronomical unit, our cosmic yardstick, the first step in measuring the universe, begins with the astronomical unit, RA. 1 astronomical unit is the average distance between Earth and the Sun above 149.6 million kilometers, or roughly 93 million miles. This unit provides a convenient way to describe distances within our solar system without resorting to unwieldy numbers. For example, the moon orbits Earth at about 0.0026 astronomical units, while Mars lies about 1.5 astronomical units from the Sun. Jupiter, the largest planet in our solar system, orbits at about 5.2 astronomical units. Even the dwarf planet Pluto, once considered the 9th planet, averages about 39.5 astronomical units from the Sun. The O also serves as a foundation for more complex measurements. It S, not just a convenient shorthanded S, a fundamental building block for calculating distances far beyond the solar system. Light years, measuring with the speed of light when distances stretched beyond the reach of the solar system. Even astronomical units become too small. To measure the vastness between stars, astronomers turn to the light year. The distance light travels in 1 year. Light moves at an astonishing speed of about 300,000 kilometers per second, or roughly 186,000 miles per second. In 1 year, that adds up to nearly 9.46 trillion kilometers, or about 5.88 trillion miles. A light year isn't a measure of time, it's a measure of distance. It tells how far light can travel in a year through the vacuum of space. For instance, the nearest star system to Earth, Alpha Centauri, lies about 4.37 light years away. That means the light we see from Alpha Centauri tonight actually left that star more than 4 years ago. Even within our own galaxy, distances are staggering. The Milky Way spans about 100,000 light years across. That means if a beam of light started at one edge of the galaxy, it will take 100,000 years to reach the other side. When astronomers observe distant galaxies millions or even billions of light years, they are literally looking back in time, seeing those galaxies as they were long before Earth even existed. The parsec, precision in the cosmos, while light years are popular in science, communication. Professional astronomers often use another unit, the parsec.
The term comes from parallax arcsecond,
And it is based on the geometry of observing stars from different positions in Earth's orbit. As Earth moves around the Sun, nearby stars appear to shift slightly against the background of more distant stars. This apparent motion is called stellar parallax. By measuring the angle of this shift, Astronomers can calculate the star's distance using simple trigonometry. 1 parsec equals about 3.26 light years, or roughly 31 trillion kilometers. The nearest star to the Sun, Proxima Centauri, is about 1.3 parsecs away. The parsec is especially useful because it ties directly to observational data, allowing astronomers to measure distances with remarkable precision, mapping the Milky Way and beyond. With these astronomical units and parsecs, astronomers can map the universe across unimaginable scales. Within the Milky Way, stars are typically separated by a few light. The Sun, for example, sits in a relatively quiet region of the galaxy, about 27,000 light years from the galactic center. Beyond our galaxy lies a vast cosmic web of galaxies, clusters, and the Andromeda Galaxy, our nearest large galactic neighbor, is about 2.5 million light years away. That means the light we see from Andromeda tonight began its journey when early humans were first learning to use tools. Farther still, the Virgo cluster, a massive collection of galaxies, lies about 54 million light, and the most distant galaxies ever observed by telescopes like the James Webb Space Telescope are more than 13 billion light years away, so far that their light began traveling toward us when the universe was still in its infancy. The expanding universe, distances that stretch with time as if these distances weren't mind-bending enough. The universe itself is expanding. This means that galaxies are moving away from each other, and the farther away a galaxy is, the faster it appears to recede. This expansion stretches the light, traveling through space, a phenomenon known as because of this cosmic expansion, astronomers distinguish between different kinds of distance. The light travel distance. How long the light has been traveling. Measuring these distances helps scientists understand not only where things are, but also how the cosmos itself changes over time. From the first observations of wandering planets to the precise measurements of distant galaxies, humanity's understanding of scale has grown exponentially. Together, these units form a language that translates the incomprehensible vastness of space into something measurable, something human. Every number, every unit, every calculation is a testament to curiosity and ingenuity. It reminds us that even in a universe so vast it defies comprehension, humanity has found ways to make sense of it, one unit at a time.